Alright, applied pre-calc. For this part, we're going to look at irrational numbers. Quite often when you're dealing with roots, you'll end up getting an irrational number. If you don't remember what that is, it's a non-repeating infinite decimal. For example, if I take the square root of 2, you'll end up getting this really long decimal. It's 1.41, I can figure that part out, but then the rest of it is just a whole bunch of random numbers, and those will go on forever. As it turns out though, some irrational numbers are just so useful to us that they get their own symbol. So they're still infinitely long, but they have a symbol sometimes designated on a calculator that we can use because we use them frequently. A couple that I've shown you are pi, which you've used before. You can't do work with circles without pi. There's the e. You might have seen the e on your calculator. That's the exponential, or the inverse, or the opposite of the natural logarithm. So that's kind of some foreshadowing into grade 12 math. And the last one here is tau. There's no button on your calculator for that, but if you get some really fancy calculators, the ones that work with unit circle, again, something you'll do in grade 12, tau is 2 times pi. Super useful for us to have, so we have symbols for them. If you punch any of those buttons into your calculator, you'll get an infinitely long and infinitely random number. The one that we can relate most to is pi, where you get 3.14159. And then what? Right, we can't really, some of you might have it memorized, but we don't know what all those decimals are. That's why we have a symbol for it. Okay, so that's a lot of theory, but let's put this into practice just a little bit. I could ask you to estimate some sort of root. Now, if you don't have a calculator, so the calculator is going to help you a lot, but if you don't have your calculator, you should be able to figure this out to a pretty close degree, as long as you know how to accurately estimate what your values might be. So the example that I've given you is the cube root of negative 50. Now I haven't shown this to you yet, but the number of the root is telling us how many of those numbers inside of the root multiply to give us that number inside of the root. So in this case, we have a 3, which is a cube root, which tells us there are 3 numbers. They all have to be the same, so I'm going to call them n, lowercase n. If we multiply those 3 numbers together, we get the big N, which happens to be the number in my root. So when I say solve for the cube root of negative 50, I need 3 numbers that multiply together to give me negative 50. So here's the tricky part. I don't know what the cube root of negative 50 is, but if you know your multiplication tables, you might want to make a table to help you out. I know the cube root of 27 and I know the cube root of 64 because those are nice cubed numbers. Negative 27 is on one side of negative 50 and negative 64 is on the other side of negative 50. So chances are, if I figure out what the cube root of negative 27 and the cube root of negative 64 are, my answer for the cube root of negative 50 should be in between those two values. So I know that negative 27 is a perfect cube of negative 3. Negative 3 times negative 3 gives me positive 9. Positive 9 times negative 3 gives me negative 27. I know that negative 64 is a perfect cube of negative 4. Negative 4 times negative 4 gives me positive 16. Positive 16 times negative 4 gives me negative 64. So my solution for the cube root of negative 50 should be between negative 3 and negative 4. Whereabouts? Well, I know the dead center would be negative 3.5. And if I take a look, that negative 50 is 14 away from the 64. And the negative 50 is 23 away from the negative 27. So it's closer to the 64, which means that negative 50 should be between negative 3.5 and negative 4. So to solve this, you don't have to draw a number line if you don't want to. I just want to have the visual. But I have negative 3 on one end, negative 4 on the other end. I've put negative 3.5 right in the middle. And because I know negative 50 is closer to negative 64, it's likely going to be one of these points between negative 3.5 and negative 4. I've chosen negative 3.7. I don't know if that's actually going to be the correct answer or not, but I know it's pretty close with my estimate because I've windowed it down to this region. If you want to test your answer, now you can pull out your calculator and see what the cube root of negative 50 is. And when I punch into my calculator, cube root of negative 50 is approximately equal to negative 3.68. The decimal goes on forever. So negative 3.7 is a pretty darn good guess. Now, just some things to watch out for that I see a lot of errors with in roots is when you're drawing your roots and you're doing, for example, a cube root, you don't want to make your number too big, because if you do, it'll look like you're multiplying a number times a root, and that happens so often. So make sure it's small, but make sure it's legible. Another one is if you're uncomfortable putting an equal sign because you're not actually writing what's equal to your problem, you can draw a squiggly equal sign. That means approximately equal to, so you get away with not having the exact answer. So I'm going to give you some practice to look at for roots. This will be a little bit challenging. I understand this very fast, but if you're working at it, I think you'll click to it pretty quickly.